Okay, in my previous videos, we have seen how to define facts and rules in Prolog, right? Even we have seen like how to query a Prolog database or Prolog knowledge base to extract information from that knowledge base, right? Or to answer some queries over there, right? Now in this video, what we'll try to do is we will try to formally define how these facts, rules, and queries are defined, okay, in Prolog. So basically we'll be starting with a simple question called like how the facts, rules, and queries, okay, or goals in Prolog made of, okay, or defined or made of, I'll say, okay, made of. So we will try to see now. The answer to this particular question is called terms in Prolog, okay. It's called terms, okay. So if we understand terms, okay, how different terms are defined and how they have how in Prolog we can define different kinds of terms, we can basically formalize or can basically create this rules, facts, rules, and queries easily. So basically we need to remember a couple of rules over there, okay. So now terms, if I just see in Prolog, terms are two different kinds of terms available in Prolog. One is called simple term, another is complex term over there, okay. So let me write it down. Now we have two different terms over here. Simple, let me write it in this way, simple term, okay, and we have complex term as well. I'll just copy this one, I'll paste it over here. Complex term, okay. So now let us try to see how this simple term and complex terms are made of, okay. So simple terms are made of two different stuffs called constants and variables, okay. Constants, okay, and second thing is called variables, okay. So now again, constant terms we can subdivide into two other different terms, okay, called atoms and numbers. We already seen what atoms are, right? So atoms and numbers over here, okay. So basically if you see it over here, like we are basically talking about at the very granular level, atoms, number, variables, and the complex term. This is what the full Prolog is like. These are the building blocks of any Prolog program over here, okay. So if we understand how to define atoms, numbers, which you already saw like previous videos, very informal way. So in this video we'll try to formalize them basically, okay. How to define variables and how to define complex terms. Now complex terms are basically using this atom, numbers, or variables, we can create more complex structure over here. Those are nothing but the complex term over here, okay. So using the simple terms, we build the complex term, okay. Complex term over here, we'll see an example as well how we build this one, and which you already saw, like how we are defining a rule or facts in a Prolog, right, knowledge base. Those are nothing but a complex term over here, okay. So now if we just start with like how to define these guys like atom, numbers, variable first, okay, we'll get a fair idea about how we can define a complex term as well, okay. And what are the places we use atoms, what are the places we use numbers, and what are the places we use variables, it will be clear as well over there, okay. Now before we jump into that part, the first thing we have to remember is what are the symbols are allowed in Prolog. Okay, so these are the symbols allowed in Prolog. So symbols, let me go down a bit over here. So the main symbols allowed in Prologs are the uppercase letters. Okay, that means our capital A till capital Z over here. Okay, so the lowercase letters as well, lowercase letters, that means our from small a till small z over here. Okay, then the underscore, that's the underscore, this is also allowed in Prolog. Okay, and apart from that we have numbers as well. Okay, from 0 till 9. Okay, so this is also allowed. Apart from that, there are some special symbols like plus, then minus, then multiplication operator or division operator, equals to, less than, greater than sign, then colon, then dot, ampersand, and then tilde operator. Okay, so these are the operators also allowed in a Prolog program. Also blank space are also, blank spaces are also allowed in Prolog over here. Okay, now let us try to see first how we can define atoms, then variables, then numbers. Okay, so we'll start with atoms. Okay, now by definition, atoms are a series of characters. Okay, a string of characters made up of uppercase letter, lowercase letter, and underscores over here, digits and underscores over here. Okay, so a string means a list of characters. Okay, a string of characters, okay, made of uppercase, lowercase, numbers, and underscore. Okay, now underscore and underscore. Now atoms with, basically the atoms always start with a lowercase letter. Okay, that begins with a lowercase letter. Okay, so this is important part over here. It has to begin with a lowercase letter. For an example, if you remember from my previous video, we defined a fact called parent over here, right? So it could be a fact name parent over here. Okay, or male, female, these are the fact names we derived or we worked on, right, in previous videos. Those are all atoms, so that means fact names are always be atoms over here. Okay, now if I just go down a bit, now atom could be an atoms could be like arbitrary list of characters. Okay, or sequence of characters, okay, arbitrary sequence of characters enclosed in single quote, enclosed in single. For an example, like somebody's name, if we are passing a constant to a particular query, right? So somebody's name like Vincent, right, and those stuff. So if you see it over here, we are allowed to use a capital letter as well. It can start with a capital letter. So now this is the atom value over here. Whatever is inside this single quotes, that's the atom value over here. Okay, now we are allowed to use space as well over here inside. So, okay, so that's why we are enclosing it inside a single quote over here. Okay, so this is another way we can define atoms as well. Okay, now there is a third way, that is a special character. Okay, now a string of special characters, let's say a string of special characters, characters, something like this one, @ equals to, which we'll see in future videos. Okay, 4 equals to 1. Okay, so it is changing that one. Okay, I will write it in this way: 4 equals to and a greater than sign, then we have a colon, colon dash. If you see it, okay, I'll just see this one, dash, then colon. Okay, so we have seen this one already when we were defining rule over there, right? And there is semicolons as well. Okay, so these are thus a very special list of characters which are also atoms in Prolog. Okay, so this will be used in very specific purposes in Prolog as well. Okay, so if you see it over here, when we write a Prolog program, every part of it, either it's an atom, or it's a variable, or it's a number. Okay, or if I just talk about everything together, it could be a complex term as well. Okay, so we are basically talking about the building blocks of a Prolog program here. Now let us talk about numbers here. Okay, numbers. Okay, so let me go down a bit over here. So numbers are generally not much used in Prolog. Okay, but there are places like we use numbers, like when we define list, right? When we define list in Prolog, so that time we use the list indexes, right? So those time we use integers over here, like minus 2, minus 1, minus 1, 0, 1, 2, 3, those stuff, right? So we use numbers in those cases, and generally in most of the Prolog system supports floating point numbers as well. Like 1, 2, 3, 4, 5, dot 7, 8, 9, 6, something like that. Okay, so these numbers as well. So there is not much to talk about numbers in Prolog. Okay, now let us talk about variables. Okay, now the main difference between an atom and a variable is, if I just copy this particular line over here. Okay, so variable can be also a string of characters which are made of uppercase, lowercase, numbers, and the underscore. Okay, but it has to begin with a uppercase letter. Okay, so this is the main difference between an atom and a variable over here. So suppose for an example, x, y, these are the variable, right? Or it can start with an underscore as well. Okay, underscore temp. So this could be another variable over here as well. Okay, now there is a special variable. There is a special variable called only underscore. Okay, so this is important. In future videos we'll see the usage of this one. It's called anonymous variable. Okay, we'll see the usage. ABLE variable, we'll see the usage of it, this one, in future videos as well. Okay, now if you see, we just defined the atoms, numbers, and variable, which is the main building block of a Prolog program, and which basically all of them are together is called simple term as well. Okay, so let me try to pull out the Prolog program we have written before and try to see what is fitting where. Okay, I just pulled that part of that program over here. I did not pull the full one. I just wanted to show you like what is what over here. If you see, like, when in this particular line we have defined a fact, right, whether Pam, we have given Pam is the parent of Bob or not over here, right? So this one, if you see it over here, this is an atom over here, right, because it starts with a lowercase letter and it's a string of like uppercase, lowercase, and it's only currently it is in lowercase, but atoms are generally string of characters made of uppercase, lowercase, numbers or underscore over here. It start with a underscore over here, start with an lowercase over here, right? Now if you see after this one, this one we still not discuss this brackets over here, right? So we will discuss now, that is the part of that complex terms over here. Okay, now let us take another one. If you see it over here, this guy over here, this is another atom, right? Because if you see it, this is this very special kind of characters over here, this one, right? So when we discussed atoms, so we discussed this part. So this part is made of atom, and this part is made of atom as well. Okay, now when we'll discuss complex terms, it will be more clear what these parts mean as well. Okay, so because complex terms are also built up by simple term as well, using these atoms and other stuff. Okay, so let us try to see now how complex terms are built. Okay, complex terms. Okay, so complex terms are built, complex terms, these are built out of a functor. Okay, out of a functor. So these things are called functor. Okay, if I just name it as functor over here, now functor, and after that, after the functor, okay, we need to have normal or ordinary parenthesis, ordinary parenthesis, and then so we need to have ordinary parenthesis and then a list of inputs over here, or list of parameters over here separated by comma. Okay, so our list of arguments over here, so have ordinary parenthesis and so, and then list of arguments, separated by comma. Okay, so list of arguments separated by comma, and then parenthesis end, then parenthesis end, parenthesis end. Okay, so now this is the basic definition of the complex term in Prolog over here. Okay, so if I just go over here, so if you see it now, these fact definitions or rule definitions, right, all are complex terms. The first part of it is an atom. Okay, we call it functor, which is basically atom type, and then we have a ordinary parenthesis start, then we have a list of arguments over here, then we have parenthesis ending over here. Okay, so this is called a complex term over here. Now if you see it, like if I just analyze this particular rule over here, right, so this part is a complex term, then we have an atom over here, then we have a couple of complex term separated by comma over here. So this is how we are defining this particular rule in Prolog. Okay, so now the arguments of this complex term could be any of these types, like it could be an atom, it could be a number, it could be a variable as well, and it could be a complex term as well. Okay, so the arguments of a complex term can be atoms. Okay, atoms. So now this is the case, this is the atom right over here, and it could be variables. It could be variables just like this one, x and y, we are using it over here, or it could be another complex term. It could be another complex term as well, like this one further. Okay, then its input is another further. Okay, then let's say x or butch, or let's say sid. Okay, so this could be a complex term where the first is an atom over here. Now inside this brackets we have a single input over here, a single argument, right? That argument is another complex term over here, right? So that particular argument has another argument over here inside this one, so that is another complex term over here. So if you see in this way, you can define a particular Prolog facts or something, okay, facts or rules very recursively as well. Now I can define a complex term, okay, that means a functor with same name but different number of inputs as well. Okay, now generally the inputs of based on the how many arguments the complex term has called arity. Okay, so number of arguments of a complex term is called arity. Okay, so if you see it over here, this particular complex term, it has a single argument, it's called one arity. If you see this particular complex term, it has a two argument over there, it's called two arity, something like that. Okay, now as I said, a particular complex term can have same name. Okay, two different complex term can have same name but different number of arguments over there. Suppose I am giving sister a complex term. Okay, let's say Anna, Nicole, Mia. Okay, so this could be one, another could be sister. If you see, I am giving the same name over here. Okay, Anna and Nicole as well. Okay, so now this particular complex term is 3 arity over here, and this particular complex term is 2 arity over here, right? Now these are the two different complex term in Prolog. Okay, so Prolog will treat them differently even though their name is same over here. Something like if you know about method overloading, okay, in modern languages, it is a similar kind of behavior over here. Okay, and generally that's the reason when we document something, document a particular complex term over here, right, or some facts or rules in Prolog, we always mention its arity over here. And how you mention, suppose if I want to mention this guy over here, I can always mention something like this one, sister. Okay, then slash its arity 3. Okay, and for this guy it will be something like sister slash 2 as well. So this is the naming convention we can write while we are documenting this stuff as well. Okay, so these are the different shades of building blocks